Welcome to episode 492 of AI Brief. And today's deep dive poses a really wild question for you. What happens when artificial intelligence stops just, generating text and actually starts simulating the physical building blocks of life? We are talking about diagnosing disease years before doctors can, and even AI learning how to inherently taste food.
I am so excited to unpack this because for the past few years, the entire tech industry has basically been obsessing over AI mastering human language. But the updates we're looking at today show that the next frontier is here. AI is now moving to master the underlying languages of human biology and, honestly, human intuition.
Right, and by the end of this deep dive, you'll understand exactly how these massive macro shifts in AI are going to impact everything from your personal healthcare to your daily digital workflows. So let's jump right into today's new updates. First up, we have a massive announcement from Mark Zuckerberg and Priscilla Chan's BioHub, which is backed by the Chan-Zuckerberg Initiative. They just launched the Virtual Biology Initiative.
And this is not a small pilot program. They are placing a breathtaking $500 million bet directly on AI biology. The stated goal here is incredibly ambitious. They aren't just trying to build better medical databases. They're building open data sets to train AI to fundamentally simulate how human cells behave.
Ultimately, the mission is to use AI to figure out how to reprogram disease right at the cellular and molecular level. And the financial breakdown really highlights how they plan to do this. Out of that 500 million, a massive 400 million is dedicated specifically to data generation and advanced imaging tech. The remaining 100 million is earmarked for external research labs.
Which makes sense because they are bringing in heavy-hitting partners for this NVIDIA, the Allen Institute, and ARC. But the core tension here is about data scale.
Exactly, and that is actually where I want to push back a bit on this. We know exactly how AI cracked language, right? It read the entire internet. The text data was already there, neatly formatted. But biology is infinitely messier than grammar. It's wet, it's unpredictable, it's constantly changing. Can $500 million really just buy the language of cells?
That is the $500 million question. Google DeepMind CEO Demis Hassabis recently made a very bold prediction that AI could eventually end disease. BioHub is essentially betting on that exact premise. But you're right about the messiness. We have a severe scale problem right now. Current biological data sets max out at around 1 billion cells.
Which sounds like a huge number to a layperson.
It does, but BioHub's Alex Rives stated explicitly that an order of magnitude more data is needed. The scientific question is whether the same scaling laws that solve protein structures will hold true for entire living cells.
But solving protein structures like what AlphaFold did that's dealing with something static, it's essentially predicting a highly complex three-dimensional origami shape. Cells are completely dynamic systems. They interact in real time, they respond to their environment, they divide.
Exactly. I like to think of it like this. A protein is a shape, but a cell is a bustling city. Simulating that city requires an unbelievable amount of dynamic data, so that $400 million going into imaging, that is literally about inventing new ways to film these cellular cities in high resolution so the AI has enough raw video to learn the traffic patterns.
So BioHub is generating the future data needed to simulate cells. But what happens if we just look closer at the data we already have today?
That brings us to our second update, and it's a remarkable development out of the Mayo Clinic that is actively saving lives right now.
Yes, the Mayo Clinic just published new data on an AI system called RED-MOD. This is a model that reviews standard routine CT scans to spot pancreatic cancer up to 3 years before human doctors typically find it. 3 years. And the numbers in this study are absolutely staggering. RED-MOD reviewed nearly 2,000 routine scans that human specialists had originally read as completely normal. The AI picked up 73% of the cancer cases early. And at the 2-year mark before a clinical diagnosis was eventually made, it spotted roughly 3 times as many early cancers as experienced human radiologists.
To understand how Red Mode achieves that multiplier, you have to understand that it's looking beyond human vision. A radiologist is trained to look for a visual anomaly, a shadow, a lump, a deformation. Red Mode isn't looking for shadows. It reads hundreds of quantitative imaging features. It analyzes complex mathematical textures in the tissue that are literally invisible to the human eye.
Oh, wow. So it's essentially doing complex algebra on the pixel density of the scan. It's seeing the mathematical signature of a tumor before the biology is even grown enough to cast a shadow.
That is the perfect way to frame it. It processes subtle gradients and pixel relationships that our visual cortex just didn't evolve to register.
Think about what this means for you and your family's healthcare. The 5-year survival rate for pancreatic cancer sits below 15%, largely because by the time the tumor casts a visible shadow, it is usually spread. Early detection is everything here.
And the best part is the frictionless deployment. Patients do not need to schedule a new, expensive, or highly invasive screening procedure. The AI simply runs quietly in the background on the routine CT scans patients are already receiving for entirely different reasons, like, say, an ER visit for abdominal pain.
It seamlessly turns existing historical data into a predictive lifesaver. So we just saw how AI is mapping the invisible mathematical architecture of human tissue. But here is where it gets really wild. Let's look at the Epicure paper just published by Kaikaku AI. This is a food robotics startup, and they are boldly claiming they have achieved a ChatGPT moment for food.
This is AI moving squarely into the realm of human intuition, and the methodology is so clever. The researchers took 6,653 messy, unstructured ingredient entries from all over the internet and rigorously cleaned them down to 1,032 usable, standardized foods. Then, they used AI to map how those specific ingredients relate to one another across thousands of recipes.
And here is the absolute aha moment in this research. The model was never given any underlying chemistry data. It had no taste labels. It was never told what sugar or salt actually tastes like. Yet, purely by analyzing the latent space meaning, which ingredients mathematically cluster together in human recipes, the model successfully identified all 5 basic human tastes.
It's incredible. It accurately ordered different types of peppers by their exact spiciness. It even perfectly tagged regional cuisines.
It's like someone who has absolutely no taste buds learning exactly what salty or spicy means just by observing which ingredients happen to hang out together at human dinner parties.
That analogy captures the mechanism perfectly. Recipes aren't just instructions. They are dense data sets of human preference. Every time a chef pairs 2 ingredients, they are encoding a tiny signal about what the human palate enjoys. Because Keikaku's model can read that hidden structural logic, they are pairing this AI with their physical robotics arm to create autonomous food infrastructure for commercial kitchens.
So AI can now intuitively drive menu development, recipe innovation, and flavor pairing tasks previously reserved purely for the gut instinct of a seasoned chef. That completely bridges the gap from digital knowledge to physical output. Now, that covers our main macro updates. Let's shift gears. For everything else happening in AI today, I'll let you take the lead on this section.
Absolutely. Let's take a look at the broader ecosystem. Just as Kaikaku is building autonomous infrastructure for physical kitchens, the rest of the tech industry is aggressively building autonomous infrastructure for our digital lives. These systems aren't just answering questions anymore, they are taking action. Starting with Google, they've significantly upgraded Gemini.
Right, the user experience is totally changing. You don't have to chat with an AI and manually copy-paste the text anymore.
Exactly. Gemini now generates files directly within Workspace and Microsoft 365 natively. You prompt it, and it natively outputs fully formatted docs, sheets, slides, PDFs, Word, Excel, LaTeX, and Markdown files. The AI becomes less of a chatbot and more of an invisible operating system.
We are seeing a really similar operating system integration with Apple's upcoming iOS 27.
Yes, reports indicate Apple is bringing AI much deeper into the native Photos app, likely to be unveiled at WWDC. They are rolling out 3 specific Apple intelligence tools. Extend, which expands backgrounds using generative AI, Enhance, which automatically fixes lighting without user input, and Reframe, which lets you completely shift the perspective on spatial photos.
And moving from visual media to the audio space, 11 Labs just launched 11 Music. It's not just a generator, it's a full streaming platform featuring AI remixing and assisted track creation. And they already have over 4,000 artists on board with a dedicated creator payout structure.
Building a web for human eyes is very different than building a web for AI agents, which brings us to parallel web systems. Founded by former Twitter CEO Parag Agrawal, they just raised $100 million at a staggering $2 billion valuation.
So while humans need graphical interfaces and buttons, AI agents do not. Parag's company is building the plumbing an entire suite of internet APIs optimized specifically for AI agents.
So agents can search, extract, and monitor the web with extreme precision for long-running autonomous tasks without getting blocked by a pop-up ad. And speaking of autonomous tasks, Mistral AI launched Vibe Remote Agents. These are specialized cloud sessions running incredibly complex coding tasks in parallel, powered by their new Open Weights Medium 3.5 model.
Which means you can spin up an army of developer agents in the cloud to tackle different parts of your code base simultaneously. Of course, with all these agents running around, security is paramount. OpenAI just released a cybersecurity action plan working directly with the U.S. government to coordinate threat responses and democratize cyber defense.
And as AI integrates globally, we have a significant, strictly factual geopolitical update regarding the AI supply chain. Two U.S. House committees have formally opened probes into two major tech players, Anysphere, the maker of the Cursor coding platform, and Airbnb.
Just to be clear, this scrutiny is entirely centered on their use of Chinese AI models in their agentic workflows. AnySphere's Composer 2 feature is built on the Kimi model, and Airbnb's internal agent utilizes Quinn.
It really underscores how global AI supply chains are facing intense regulatory oversight. The models powering autonomous agents are becoming as geopolitically significant as the silicon chips they run on.
Let's bring this all down to earth and move into our final section for today. How can you, listening right now, leverage this expanding ecosystem to boost your own productivity? Let's run through today's trending AI tools and practical use cases. First up, Slides Go. I've tried generating slide decks before, and the design usually gets completely mangled.
Right, but Slides Go essentially decouples the raw data from the design layer. You provide the core data points, and it dynamically structures a visually compelling pitch deck. It acts like a junior graphic designer, letting you focus entirely on the narrative.
That concept of removing production friction extends to video, too, with HeyGen. It's a tool for creating AI avatars and video clones of yourself. You record a baseline avatar once, and from then on, you can generate professional corporate training modules by just typing text. No camera setup, no lighting adjustments.
We see that same scaling principle in audio with Void Magic. They specialize in high-quality vocal content through advanced voice cloning and custom voice synthesis. If you are an audiobook producer, this lets you generate pristine, emotionally resonant audio performances at scale without booking expensive studio time.
Now, those are great for static assets. But for generating complex interactive systems, we have SoonLab. It turns a single text prompt into a fully playable game in seconds. It isn't just spitting out static code.
No, SoonLab dynamically assembles logic, physics rules, and visual assets on the fly. For developers or educators, you can simulate physics environments or build interactive learning modules instantly.
We also have Zooclaw, which feels like a glimpse into the future of enterprise work. It allows you to assign specific tasks to specialized AI agents, each with structured domain knowledge and a native-sounding voice.
Instead of one monolithic AI trying to do everything poorly, Zooclaw is like hiring a digital team. You have a specialized financial agent crunching numbers, who then seamlessly writes that data to a specialized marketing agent to write the copy based on their core competencies.
To power those kinds of localized, specialized agents, Xiaomi just released Mimo V2.5 Pro. It's an open-source model providing high-performance computing capabilities that can run locally on your own hardware, which is massive for enterprise privacy.
But if you want the bleeding edge of cloud capabilities, OpenAI introduced GPT 5.5. This frontier model is optimized specifically for agentic coding and computer use. It can actually navigate your desktop, open files, write code, run terminal commands, and debug errors autonomously.
And finally, if you want to build those autonomous capabilities directly into your own software, check out the new Cursor SDK. It allows developers to take Cursor's highly capable coding agents and embed them inside their own external workflows. It basically lets any company offer top-tier agentic coding features to their users.
It is the ultimate democratization of the digital workforce.
So wrapping up this deep dive, we covered an incredible arc today. We explored BioHub's $500 million push to decode the dynamic language of cells. We saw the Mayo Clinic's RedMoD spotting the invisible mathematical textures of cancer 3 years early. We learned how Kaikaku AI decoded the intuitive taste of a master chef just by looking at hidden ingredient patterns. And we mapped out how the entire tech ecosystem is building autonomous infrastructure for our digital lives.
And if we step back and look at the common thread here, if an AI can map the exact cultural nuance of a regional cuisine just by analyzing ingredient combinations, and if it can spot a deadly cancer by finding microscopic mathematical textures, it raises a really profound question. What other deeply human intuitions or gut feelings are actually just hidden data patterns waiting for enough compute power to decode them?
That is a fascinating thought to leave you with as you navigate this rapidly changing ecosystem. Thank you for joining us on this deep dive. Be sure to follow the podcast, share the show with someone who needs to hear this, and stay insanely curious. See you in the next episode.